So today we will discuss about Cauchy sequences. So first of all we will start with what we mean by a convergent sequence. A sequence in a metric space is called convergent if there exists a W naught belongs to that space omega such that for every epsilon greater than 0 there exists a natural number n such that Zn minus W naught is always less than epsilon whenever n is greater than or equal to n. So this is what we mean by a convergent sequence in a metric space where the modulus is just given by the metric of the space and the space is omega. But note that in this definition we require an estimate which is W naught to check if a sequence is convergent, which is not a really good way to check. So we want to have a method which doesn't require us to take any estimate, and that's where the concept of Cauchy sequences come. So definition: a sequence is called a Cauchy sequence if for all epsilon greater than 0 there exists a natural number n such that Zn minus Zm is less than epsilon whenever n and m are greater than n. So this obviously doesn't require us to estimate any limits, say. So this is definitely a nice way to say categorize a sequence. So now we want to answer if a Cauchy sequence always converges or are all convergent sequence Cauchy. So we will answer that in our next theorem, which says that if a sequence is convergent, then it's Cauchy. So we will look into the sketch of this proof. So since the following equation is convergent, we know that for every epsilon there exists n belongs to natural numbers such that first Zn minus Z naught, say the limit is Z naught, so less than epsilon by 2 for all m and n greater than or equal to n. So now we will look that so from triangle inequality we can say that and hence the rest of result follows. So yeah, so we have proved that every convergent sequence is Cauchy sequence. So is the converse true? Is every Cauchy sequence a convergent sequence? And the answer to that question is no. Not every Cauchy sequence is convergent. So we define another object, so a space or a metric space where all Cauchy sequences are convergent is called complete. So this is what we mean by a complete space. So in complete space, then a sequence is Cauchy if and only if it is convergent. So hence we will just analyze the complete spaces, since the notion of Cauchy and convergent sequence is identical in them. So we won't prove the next theorem, but we will take it as an fact that R is complete. We can also prove it, it's quite simple, but we will not do that here. So yes, this is the crux of what we mean by Cauchy sequence, and we'll use that heavily in our next videos.